Hey guys, welcome back to the next video. In this video, we are going to understand about the cloud native reference. So this complete architecture is going to be about the cloud native, understanding the cloud native, and then we are also going to see the reference architecture for cloud native. So what is cloud native? Let's just try to understand what is cloud native. Cloud native application consists of discrete reusable components known as microservices that are designed to integrate into any cloud environment. Cloud native refers to less of where an application resides and more of how it is built and deployed. So, what is cloud native? If that's the question, the answer is very simple. Cloud native refers to where actually it doesn't care about where exactly your containers are going to be residing upon, but it all worries or what it cares about is like how your containers are built and how the deployment process happens. So that is basically your continuous integration and continuous deployment, how it's going to happen in terms of the cloud native. That's the whole thing which you need to worry about, because you are going to have containers which is reusable, which is rebuildable, and can be built across in any cloud cloud microservices platform where containers are present. A cloud native application consists of discrete reusable components known as microservices, which will be hosted on top of containers. That's basically why we are creating microservices. These microservices act as building blocks and are often packaged in a container. Microservices works together as a whole comprise an end application, yet each can be independently scaled, continuously improved, and quickly iterated through automation and orchestration process. The flexibility of each microservices adds to the agile and continuous improvement of cloud native applications. So that's what cloud native is all about. The next one we are going to talk about CNCF, cloud native definition. Now, what is CNCF is basically your cloud native computing foundation. Now, remember when Google came up with Kubernetes, right? So they end up giving the Kubernetes to this foundation, computing foundation for cloud native. So this foundation basically is created with the open standards in mind to make sure that containers can be built one place, and then those containers can be executed anywhere. So that is the whole intention of having it. Cloud native technology empowers organization to build and run scalable deployment or scalable application in modern dynamic environments such as public, private, and hybrid clouds. Containers, service meshes, microservices, immutable infrastructure, and declarative APIs exemplify this approach. These techniques enables loosely coupled systems that are resilient, manageable, and observable. Combined with robust automation, they allow engineers to make high impact changes frequently and predictably with minimum toil. A cloud native solution or the cloud native computing foundation seeks to drive adaptation to this paradigm for fostering and sustaining an ecosystem of open source vendor neutral projects. So that's the main motivation behind cloud native computing foundation, to make sure that whatever you guys are doing with cloud native solutions are redeployable anywhere else on any of the public, private, and hybrid clouds. There are 12 app factors or app methodologies which you need to understand. So this may be part of your examination questions in terms of your writing certification on this. 12-factor app methodology is coming up with the code base. Now, what is 12-factor app methodology? It's a methodology for building software as a service. So if you're planning to build a cloud native deployment, these are the 12 application methodologies which you have to use in terms of making an application as a software as a service. In terms of code base, one code base tracked in a revision control with many deployments, and in terms of dependencies, explicitly declare and isolate dependencies. And in terms of config, it stores configurations in the environment. In terms of backing service, treat backing service as attached resource. In terms of build, release, and run, it strictly separates build and run stages. In terms of process, it is more of a stateless process. And then you have port bindings, concurrency, disposability, dev or prod, parity. You have logs, and you have admin process. So these are some of the 12 factors application methodology where the cloud service, has this in terms of creating a software as a service. So moving on to the next one in terms of comparing the cloud native and microservices. A microservice is a small application with a small footprint that performs a specific function. Microservice enables an architectural approach where a much larger application is composed of discrete, independently deployable components. Microservices works well with cloud-native applications because of the modular structure, compatibility with Agile and DevOps process, and harmony with container use. So remember that these are some of the cloud-native and microservices principles to work with. So the next one we are going to talk about is cloud native versus cloud enabled, cloud ready, cloud based, and cloud first. Cloud native versus cloud enabled is cloud enabled is developed for development in traditional data centers, but later changed into cloud environment. In terms of cloud-ready services or software designed to work over the internet or any application that works in a cloud environment. Same thing goes for cloud-based as well, a general term that is applied for various cloud offerings that can deliver over the internet. Cloud first is a business strategy in which organization commits to using cloud resources first when they are launching new IT services or refreshing an existing services, or replacing a legacy technology. So this is all the other aspects, as in just like cloud native, you also have cloud enabled, cloud ready, cloud based, and cloud first. These are the terms, and in these situations, these are used. The next item we are going to see as part of this is the cloud native development principles. So the first one is all about the follow the microservice architectural approach by breaking application down into single function service. These services are loosely coupled but remains independently, allowing the incremental, automated, and continuous improvement of an application without causing downtime. In terms of the second point, they rely on containers to maximize flexibility and scalability. A container package software which with all the code and dependencies in one place, allowing software to run anywhere. This allows maximum flexibility and portability in multi-cloud environments. Containers allow fast scaling up and down with Kubernetes orchestration policies that are defined by the users. So these are some things which we already discussed about in terms of microservice architectural approach, as well as maximum flexibility and scalability in terms of containerization. And the last point is adopting agile methods to speed up the creation and improvement process. Developers can quickly release different versions updates based on the feedback, allowing them to work with application versions closely with the end user experience. So you will understand about the container cycle. So in that, I have discussed about how the containers starts from working with this kind of feedback loop and updating the containers based on the feedback loop. The next component we are going to talk about is the what are the critical cloud native components which we have right now. The first one is package. The critical component is that packaged as a lightweight container. That's one thing. Designed as a loosely coupled microservices, deploy on a virtual, shared, or elastic infrastructure, which includes cloud, that supports horizontal scaling. The use of lightweight APIs that are based on protocols such as restfulness state transfer, or easily called as REST. I think it's a representational state transfer. I'm sorry about that. I was just looking at somewhere else. Use a service mesh for handling service-to-service communication, managing through agile DevOps process or CI/CD pipeline. So these are some of the critical components of cloud native component. And other attributes towards the components are basically how the communication happens, like each service, how they interact with the language module, and then separate of statefulness and statelessness, and then policy-driven resources provisioning and zero downtime. These are some of the other principles of your or other components of your cloud native solution using microservices. Now, the next concept we are going to understand is service mesh and what are the use of service mesh. A networking model that sits in the layer of abstraction above TCP/IP layer, responsible for reliable delivery of requests throughout the complex topologies of services that comprises a modern cloud native application. A service mesh is a networking model that sits, as I told you earlier, it's abstraction above TCP/IP. It is responsible for a reliable delivery of request. So that's something I want to summarize again. It is typically implemented as an array of lightweight network proxies that are deployed alongside of application code without the application needing to be aware. The concept of service mesh as a separate layer is tied to the rise of cloud native applications. In the cloud native model, a single application might consist hundreds of services. Each services might have thousands of instances, and each of those instances might be consistently changing their states, and they will be dynamically scheduled by the orchestrator like Kubernetes. Not only a service communication in this world is incredibly complex, it is also fundamentally important for the runtime behavior. Now, how service mesh is going to help here is that it's going to be, again, abstract above TCP/IP layer. It's going to sit as a separate layer itself, wherein which all the communication which is going through between all these hundreds of services, between those thousands of instances, that all will be going through this service mesh, and the service mesh is it will act as a local network proxy, and then it will route the request to whoever is requesting for that information. So that's the usefulness of service mesh. And in terms of the cloud native reference architecture, so there are these steps. First is like you are a developer, develops your content in the next gen development experience, and then they get to host your application, which is developed with the next gen development experience in the certified containers. And then the third step is the Kubernetes workload, wherein which the Kubernetes will make sure that the deployment happens autonomously using the CD/CI pipelines or DevOps pipeline. It pretty much summarizes the architecture, reference architecture. In terms of the cloud native reference architecture, there are these three things which you need to look at. One is the security, service management, and DevOps. So cloud native architecture must satisfy several non-functional requirements. So these are security, service management, and DevOps. Security, secure application using certificate management, microservice-based network policies that controls application access, and distributed denial of service protection or mitigation on the web application firewall level. So you can also use TLS encryption authentication for mutual authentication as well as part of the security. And in terms of service management, a non-functional requirement includes health check, logging metrics, and distributed tracing. In terms of DevOps, is not a strict requirement for your application, but CI/CD pipeline is often cited as a pillar of successful software development and DevOps practice. So these are some of the cloud native reference in terms of the architecture. And then we have the last slide over here. This slide talks about cloud native approach, development approach here. So here it talks about somewhere around 12 principles over here in terms of cloud native approach, development approach. The first one is like when considering the right cloud architecture for your application and workload, you must begin with unique need of your business. This may include the factors such as government regulations, security, performance, data resilience, data residency, where your data is stored, service level, then time to market, architecture, complexity, skills. This is all I can think of. The second one is the right model, the right cloud model depends on your workload. You should understand that the pulse and the minutes of each cloud deployment model and takes the methodology approach for determining which workload to move to which kind of cloud to maximize the benefit. And next one is about getting started with the latest technologies like AI, machine learning, blockchain, or Internet of Things requires an understanding on how they work and what they do. Proven reference architecture for using them, plus a knowledge on development practice such as design thinking or learn startup or agile and continuous delivery position your design, delivers and validates your idea very quickly. So these are some of the, in terms of having knowledge on newer technologies. In terms of the fourth strategy for great success, to help you to define the cloud strategy, look for experienced partners who may meet you where you are in the cloud journey, helping you to decide a proper future for you in terms of drawing roadmap and to get there. These are the strategies for a great success. In terms of finding freedom to innovate with emerging technologies, you need freedom to build to your unique business specification. An architecture that is built on open standards is the foundation of innovation in the cloud solution. So look for opportunities to maximize your productivity and deployments on an open standard based cloud systems. Not only does the next point is like number 6 is not only does your underlying infrastructure needs to be built on open standard, but it also must deliver capabilities to accommodate the newer technologies and the data which fuel them. You always remember that the AI data-driven workloads are rapidly scalable and affordable, and they have affordable storage options. In terms of the finding freedom on the point number 7, With the cloud native development, you can deliver enterprise grade product in days and weeks versus the traditional monolithic process that takes even months. So this meets the consistently changing business demands to easily updating your application multiple times a day. In terms of point number eight, microservices mean speed and quality, which also includes small and mighty microservices. In terms of the ninth point, container technology is a perfect match with the microservice architecture because it supports the smaller and faster nativity. In terms of point number 10, maintaining order with orchestration, you must be able to monitor, manage, scale multiple components in your microservice architecture by using orchestration option. Which ranges from open source tool like Kubernetes for containers and management platforms like platform as a service like OpenShift it's another example if you're going for enterprise architecture in terms of managing your application. So to iterate, to innovate with DevOps, as in like to version your innovation with DevOps. The first option, the option number one is like when DevOps is fully ingrained in your culture, your team and process performs in the concept with your technologies is to keep the dynamic demands. Cloud native changes the relationship between the development and operation teams. So on a whole, transformation into a different culture of work is going to happen in terms of moving to DevOps. So that's more or less what we wanted to discuss in terms of non-functional requirements. Then what we're going to do on the next video is to learn more about hands-on in terms of containers. That's what we're going to do right now in the next video. In the next section or sub-project. So we will get on with that. Thanks again for watching this video. I'll see you on the next one.